Hello everyone, my name is Yash. I am a software engineer here at Google. I've been working on gRPC since 2017.
And I'm Abhishek, also a software engineer with Google. And I've traveled from India to be here and talk about some of the exciting things that we have been working on in the last year. And that's
gRPC observability. Right, here's the agenda. We are going to try to put a spotlight on all of the cool stuff we've done in the past year, mostly around OpenTelemetry. We'll do that, but we also wanted to use this opportunity to put a spotlight on some of the other tools we have in the ecosystem so that we have a more complete view of what we can achieve with gRPC observability today. All right, so as promised, we're going to start with gRPC's integration with OpenTelemetry, which is an open source observability framework that was a successor, is a successor to OpenCensus and OpenTracing. I'm not going to have the time to do a demo today, but we have a nice guide, YouTube video, code labs to help you get set up. And with minor code changes, you can set up the plugin and have all your data, including deep gRPC state, exported to any backend that has a supported OpenTelemetry exporter. For example, if you're dealing with Google, you would have Google Cloud's monitoring exporter or tracing exporter set up and have all of your observability displayed. Right. Folks familiar with OpenTelemetry would know that OpenTelemetry has its own RPC semantic conventions. When we started the effort to support OpenTelemetry with gRPC, we, the maintainers, felt that the conventions were too generic and not specific enough. Any RPC system probably has nuances that are unique to that system, and those ideally would need to be captured by metrics. So for gRPC's needs, we needed to be able to define metrics and traces that worked for gRPC. So we use gRFCs, that are gRPC's version of RFCs, and defined how gRPC's OpenTelemetry plugins would work. And we've added a bunch of metrics and traces that have already been implemented. We still have an ongoing collaboration with the OpenTelemetry community, and there are talks of gRPC helping with the development of the OpenTelemetry RPC semantic conventions. The thought is that we might be able to get some out-of-the-box observability for RPC systems in general, so there might be some sort of a compatibility story on the cards. All right, let's start with the new stuff, OpenTelemetry tracing. We don't yet have a user-friendly guide, but the gRFC is available for anyone interested. In brief, what this gives us is a lot of information as to what is happening in the life of a request in a distributed systems environment. Usually a small number of requests, let's say 1 in 10,000 or 100,000 requests are sampled. And for each sampled request, the trace helps you get a tree-like structure for all the spans which represent individual tasks. So let's say a user request reaches the server, and the server further makes requests to other services. You'd be able to see the new RPC as part of the same trace, along with a time graph as to what happened when. Previously, we had the gRFC for OpenTelemetry tracing get approved and merged. In the past year, we've had it implemented in Java, C++, and Go, but it is still in experimental status. We're just trying to dot the I's, cross the T's, and get some cross-language interop tests to make sure that it is working as we intended it to before we call it stable, hopefully soon. Right. We now also have TCP traces instrumented in C++. With this, along with the previous message events of outbound message, we also see events, 4 of them, which show when TCP packets are passed to the kernel, the send message syscall, scheduled by the kernel, when they're actually sent, and when they're acknowledged. Along with this, we also get some stats that gives us stuff like delivery rate, a min RTT, retransmission, congestion, and more. As detail, we do this by sending down control messages along with the send message syscall to tell the kernel that we are interested in these timestamps. And we've used this feature quite successfully within Google in our debugging efforts to determine whether we are running into network problems or alternatively to rule out network trouble as a cause for high latencies. At present, the machinery to do this is only available in C++ on Linux kernels, but maybe we'll be able to add it for other languages in the future. All right, I'm going to have Abhishek talk about metrics next.
Thank you. All right, so we have talked about tracing. Now let's jump over into the world of metrics. And like many things in gRPC, it's an evolving area. But before we get into the what, let's talk about the why. Why should we even care about metrics in the first place? Well, think of it in this way. Metrics are how our services talk to one another. They are fundamental to understanding the health and performance of our gRPC applications. They give us the visibility we need to monitor and optimize what's really happening between our clients and servers, helping us pinpoint performance bottlenecks. This also acts as an early warning system, allowing us to proactively find issues by tracking things like latency and error rates before they ever impact our services. And at the end of the day, using metrics is a cornerstone of building better systems, scalable and reliable applications that we can truly trust. Today, we'll try to share a holistic view of the metrics available with OpenTelemetry in gRPC. All right, let's start with some of the existing ones. When you look at the client metrics on this slide, you'll see that two might seem similar, per attempt and per call. It's a great question to ask what the difference is. And the answer actually highlights the key reason why we choose to introduce our own metric semantics rather than using the standard OpenTelemetry ones. To understand why, let's break it down. In gRPC, a single call that you make in your client application can actually result in several attempts to the server, especially anytime you use features like retries or hedging. This leads to a natural follow-up question. Why doesn't the server have per attempt metrics too? The reason is that the whole concept of an attempt is really a client-side story. The client is the component that contains the logic to say, oops, that failed, let me try again. From the server's point of view, each of these attempts, even the retries, look like a brand new independent request. The server's job is simply to handle each incoming request it receives. So its metrics are designed to reflect that per request reality. All right, now let's switch gears and talk about some of the new metrics that we have been adding. We have been busy rolling out a bunch of new metrics to give you a much clearer picture of what your gRPC applications are doing. First up, for retries and hedges, if you have used OpenCensus before, this will probably look familiar. We have brought some of the great functionality over, so you can now track retries, hedges, and even the delay between them right in our new telemetry implementation. We mentioned WRR and XDS the last time, and I'm happy to say that the WRR metrics have been implemented in Core and Java and Go, while the XDS metrics have been implemented in Core and Java. Cool. Next up are the new subchannel metrics, a big improvement for connection visibility. With the earlier pick first metrics that these replace, it was a bit confusing to have subchannel metrics coming up as pick first, even if it was not explicitly configured as the load balancing policy. Also, there was no way to get the actual disconnection error with those metrics. Now, you can tell the cause, like socket errors, go away, connection timeouts, behind a connection getting disconnected, which gives a much clearer view for debugging. Now, I want to zoom in on two additions that here that I'm particularly excited about. First, these outlier detection metrics. This was an awesome contribution from our friends at Dropbox. It's a perfect example of how the community is making gRPC observability better for everyone. So a huge shout out to them. Second is this new optional label, gRPC-LB backend service. So what does this actually do? It holds the name of the backend service you're calling. If you have one client talking to many different backends, this label is a lifesaver. It lets you easily slice and dice your metrics for each service, so you can exactly see what's going on with each one. And just a quick heads up, we are working hard to get all these new metrics into every gRPC language. But they might not all be there just yet. We are rolling them out progressively, so it's always a good idea to check the docs for your respective languages to see what's currently available. All right, so what's next for metrics? We want to go even deeper, right down to the transport layer itself. We are working on a proposal for some new TCP level metrics that will help you understand what's really happening on the wire. Right now, if you have a tricky network problem, it can feel a bit like a black box. These new metrics are designed to shine a light in there. For example, we are planning to add things like TCP min RTT, which will give you a clear best case look at your network latency. TCP delivery rate, to show you the actual data throughput you are getting. And this is where it gets really powerful. Metrics for packet sent, packets retransmitted, and even spurious retransmissions. This will give you a super detailed breakdown of what's happening at the packet level, which is used for diagnosing those intermittent, hard to find network issues. Now, I want to be clear. These are still in the proposal stage, so you can't just use them yet. Think of this as a sneak peek into where we are heading. Cool. That was all the work we have done with OpenTelemetry in the past year. Now let's look at some other tools that we have in the ecosystem to supplement the observability from our OTelemetrics and traces. Let's talk about a really handy tool in our toolkit, gRPC binary logging. At its core, it's a feature that lets you record your RPCs in a binary format. This is super useful for a few key reasons. First, it's really useful for troubleshooting. When you're trying to debug a tricky issue, these logs give you a perfect record of the requests, responses, and statuses, helping you find the root cause of a problem. You can also use these logs for load testing by analyzing real traffic patterns from production to see how your service holds up. But one of the most powerful things you can do is replay RPCs. Imagine capturing a log from your production environment and then replaying the exact sequence of events in a dev environment. It's an amazing way to reproduce and squash bugs. Getting it set up is pretty straightforward. You just need to set an environment variable, usually something like gRPC binary log config, depending on the language you are using. In that configuration, you can get really specific, telling it exactly which services and methods to log, and even set limits on the message sizes. Now, you might be thinking about security, and that's a great point. We designed binary logging with security in mind. The log format intentionally separates the metadata, like headers, from the actual message payload. This makes it much easier to set up filters to control what gets logged, so you can avoid accidentally leaking sensitive data like passwords or encryption keys. Cool. Let's move to a fantastic tool from the community, gRPC curl. Simply put, gRPC curl is a command line tool that lets you interact directly with gRPC servers. The name pretty much gives it away. It's a curl, but for gRPC. This means you can send gRPC requests and get responses right from your terminal. Now, I do want to mention that while gRPC curl isn't a tool that is officially maintained by the core gRPC team, it is incredibly useful for a few key things. First, It speeds up testing and debugging dramatically. You can quickly fire off an RPC to an endpoint and see the exact server response without having to write a single line of client code. It's also amazing for API exploration. If a server has reflection enabled, you can just point gRPC curl at it and ask, hey, what services and methods do you have? It will even show you the exact schema for requests and responses. And finally, since it's a command line tool, it's perfect for scripting. You can easily integrate it into your shell scripts for things like automated testing or health checks. Here's a quick example of how you might use it. Next, I'll hand over to Yash to take us through some of more tools.
Thank you, Abhishek. So channelz, I'm assuming many of you are already familiar with this. So we've got this term admin services that currently encompasses two services, channelz and CSTS. Both of them are services that can be added to a server, like in the example shown on the screen. And once you have these services being served, you can query them using RPCs as usual. channelz in particular provides information on channels, subchannels, servers, sockets. It will give you answers to questions like, what's the state of my channel right now? Give me all the recent events on my channel or subchannel. Or if my RPCs are failing, is there something wrong going on with the particular subchannel? Additionally, to make life simple, as part of the gRPC ecosystem, we have a helper UI tool that fetches the data for you and presents the data in a nice, easy-to-consume fashion. The images are taken from the blog itself that's linked above. It's a really useful guide written by Yushuan that shows an example on how to use channelz and the UI tool itself. We also have a work-in-progress gRFC for channelz v2 that Richard mentioned earlier as well. And the aim is to make channelz more generalized so that the relationships between the various nodes is more loose and so that we can record more types, not just servers, channels, subchannels, and sockets. Note though, this is still a work in progress, so not a done deal yet. So please keep posted on the gRFC. The next thing we want to mention is gRPC debug, which is a command line utility that allows you to query processes running gRPC. How it works is that it just acts as a gRPC client and queries the services exposed by gRPC application. As shown, the commands that supports are channelz. So in case you're unable to use the UI, you can use this. You've got health using the health check service, so you can check whether the server is serving or not. And XTS, which uses the previously mentioned CSTS or client status discovery service. So if you have an XTS-aware gRPC application running, you can use this to check the status of the various XTS resources and get a dump of the configuration as well. Just some quick examples on what it looks like. So a usual command line utility, which shows you the response for the various RPCs. Those are all the tools that we have in our arsenal at present, and we don't believe we are there yet. As we continue to use gRPC, we come across shortcomings, and we try to improve the observability to try to address those. And we're really happy that we're able to engage with the community to get feedbacks and ideas as well. As a quick summary of what we've discussed, this is our immediate roadmap of what we're going to get done in the short term. Imagine a few quarters. Additional metrics, this includes implementing the TCP level metrics we discussed earlier and rolling out the new subchannel metrics and outlier detection to more languages, including C++, Go, and Java. We're going to get tracing stabilized, interrupt tests, and whatnot. And finally, latency. This is a profiling tool in C++, well, core really, that helps you visualize and analyze the latency of your gRPC program, and it outputs the data in a format that's recognized by tools like Perfetto. This is already kind of instrumented, but the way to get the data out is not really user-friendly right now, so there is work in progress on this. Right, thank you. That's all we had. We'll take questions now. We don't seem to have a lot of time because there is a happy hour scheduled at 5. But there is no time limit to us. We are happy to take any questions.
Thank you. This is wonderful information. There seems to be a tendency towards unary RPC when it comes to observability matrices and tracing.
True.
As you probably know, the bidirectional stream and clients often cling on to the same stream through the entire lifecycle, and it abstracts away individual requests or messages goes on the stream. So what level of observability improvements, if you will, that you have in mind for this?
Right. So far, I'd say the past couple of years, our focus has been on unary RPCs because that's the 90% of the use case in the world. Bidirectional RPCs, I guess the only support right now is really the outbound and inbound messages and seeing the message counts. But that's not great in terms of the other observability like metrics. For example, if you have a latency metric for BiDi streaming, that's not really useful, right? Like if you see latency saying 1 hour, what does that even mean? So this is an area of possible improvement, and we are trying to think through what possible observability we could provide for that. channelz is one way that kind of helps to see how many calls are still ongoing and stuff like that. But yes, we are really eager to know what the community thinks, and if you have ideas as to what might be useful, please let us know.
Similar question. Is binary logging supported for bidirectional streaming, or is that only for unary?
It doesn't matter whether it's BiDi or unary. What it really does is it just takes what events are generated on the RPC and just logs them out, right?
Is it logging per message then, or?
Yes, you would have different events for each message, right? So I believe the message events are like send message or receive message, right? So for unary, you just have one of them, one send message, one receive message. BiDi, you just have multiple of those.
I see. Thanks.
Any
other
more questions?
And again, please feel free to catch us outside. We'll be right there hanging out. But yes, it's time for the happy hour. Thank you, folks.
Thank you.